Hello students, welcome back to my YouTube channel Mathematical Lens by Ganitha. In this video, we are going to continue with chapter number 7, Fractions, Grade 6 Mathematics of the new NCERT textbook Ganitha Prakash. And we are going to cover the last part of this chapter, a pinch of history. So let us see what a fraction was called in ancient time. So it was called as bhin in Sanskrit, which means broken, right? It was also called as bhag or ansh, which means a part or a piece, right? So the way we write fractions today, globally it originated in India. In ancient mathematical text, if you see such as Bhakshali manuscript is the one which is written by hands. So it is around 300 CE. So they wanted to write half. They wrote it as 1 and 2 like this, which is indeed very similar to the way we write today, right? Only the differences between this line. This method of writing, working with fractions, continued to be used in India, right, for several centuries, including it was used by Aryabhatta in 499 CE, then Brahmagupta. These are all great mathematicians of India in 28 CE. Then Sridharacharya in 750 CE and Mahaviracharya in 850 CE. So these people were using this symbol 1. This is half without the line 1 upon 2, that is, right, which we called it as half now. So this line segment between the numerator and the denominator in half or in other fractions, that was introduced by a Moroccan mathematician, right, and his name was Al-Hassar, which was in 12th century. So over the next few centuries, the notation then spread to Europe and around the world. So it spread and people started using this way of writing fractions. Okay. Now fractions had also been used in other cultures such as Egyptians, Babylonian, their civilizations also, but they primarily used only fractional units. That is fractions with a 1 in the numerator. More general fractions were expressed as sum of fractional units. Now, like for example, they are called as Egyptian fractions. So writing numbers as the sum of fractional units, example 19 upon 24. So then it was written as 1 upon 2 plus 1 upon 6 plus 1 upon 8. Right? So this part was not used. They would say it is half plus 1 6 plus 1 8. So only fractional units were used at that time. It can be an art and leads to beautiful puzzles, right? So we will consider one such puzzle below and we'll try to solve that puzzle also, right? Now general fractions where numerator is not necessarily 1, right? The Egyptian, they used only the fractional unit, that is the numerator as 1. So these were first introduced in India, the other fractions, right, along with their rules of arithmetic operations like addition, subtraction. We also learned Brahmagupta's method of addition and subtraction, right, and even multiplication, division of fractions. These were introduced in India, right, and they were known as, the treaties were known as Sulbha Sutras, right. Shows that even during Vedic times, Indians had discovered the rules of operations with fractions, right? Isn't it amazing? So the general rules, which are known as the Sulbha Sutra, right, and procedures for working with and computing with fractions, they were first codified formally and in a modern way by Brahmagupta. The methods which we just learned in the previous videos, in the previous part of this chapter itself. So Brahmagupta's method with and computing with fractions are still what we use today. They are still valid and applicable and they are easy to use. So Brahmagupta described how to add and subtract fractions as follows. So we learned this earlier by converting both of them into equivalent fractions, like multiplying the numerator and denominator by the other denominator and then or taking a common denominator in case of addition as well as subtraction. And once the denominator is same, we can add the numerators or denominators, right? So in case their difference is taken, Brahmagupta's, Brahma's, it is Siddhant, verse, there is a verse for it, the sutra which is there, uh, it is there in for subtraction. There is the difference which is taken, right? So the Indian concept and the methods involving fractions, they were then transmitted to Europe via Arabs, right, over the next few centuries, and then they became into general use, right, and in Europe around in 17th century, and then it spread worldwide, right? So this is a bit of history about the Brahmagupta's Sutra. Now there are puzzles which we'll try to understand and then solve. So let us see the puzzle. Now it is very easy to add up fractional units to obtain the sum as 1. Like first one is half plus half is 1, right? 2 halves make 1. Then 3 1/3 make 1. 1 plus 3 plus 1 plus 3 plus 1 plus 3. You can even understand it by diagram. Half plus half makes 1. Like if there is 3 parts, then 3 1/3 will make 1 whole. Then 4 1/4 will make 1 whole, right? So you can visualize and even write it 1 plus 4 times 1/4 will give you 1, right? Now can you think of a way or to add fractional units that all are different to get a 1? All should be different. Now here you have taken half, right? So then you need to take some other fractional unit to get 1. So it is not possible to add 2 different fractional units to get 1. What is the reason? Right? The reason is that half is the largest fractional unit, right? This we understood, that out of this half is the greatest, then comes 1/3, then comes 1/4, right? So if we take half, this portion is half, and this, whatever we take, it will be either 1/3 or 1/4, right? So suppose we take 1/3. So you cannot have the total as 1 because the other fractional unit will be less than half, right? So to get different fractional units, we would have to replace the at least one of the half. There are 2 halves. So 1 half we kept here, and if we try to replace the other half will be, its value will be less than half. 1/3, 1/4, 1/5, whatever you take, its value will be less than half, right? So you will not be able to complete this circle. You will not be able to make it 1 full, right? So the sum will always be less than 1. If I try to shade this part, right, this is half plus 1/3. I have taken the largest after half. So there is some portion left over here. So we are not getting 1 whole, right? So therefore it is not possible for 2 different fractional units to add up to 1, right? It can only be half plus half, right? Now we can try to look instead for a way to write 1 as the sum of 3 different fractional units, right? Just now we saw that 3 1/3 make a whole, right? They are all same. But now what do we need? 3 different fractional units that add up to 1. So it turns out there is only one solution to this problem, to changing the order of the 3 fractions, right? Can you find it? Let us see. We'll understand it in a systematic way. So we have understood that 1/3 plus 1/3 plus 1/3 gives you 1. Now to get fractional units to be different, we want all 3 different. We'll have to increase at least one. This one of the 1/3 has to be increased, right? And decrease at least one of the 1/3 to compensate for that increase. Because if you increase one, the other should be decreased. The value of the other should be decreased. Then only you can get the whole. Now the only way to increase 1/3 is only half. That's the only way. You remember half is the largest fractional unit, right? Unit fraction. So and the next is 1/3. This we have understood. Half is greater than 1 upon 3 and half is the only one. So for replacing 1/3, one of the 1/3, we have only one option, that is 1 upon 2. Right? So if we have replaced half, then if we want this, if we divide it, this is 1/4 plus this is 1/4. Right? Now to get the fractional units to be different, they are not different, only two are different, two are same. So we have to increase one of the 1/4s, right? And decrease the 1/4 to compensate. There are two 1/4s. So one has to be increased, the other has to be decreased. The value has to be decreased. Now what is greater than 1/4? It is only 1/3 or half we have already used. Remember this sequence. Right? So what is greater than 1/4 is 1/3. So if we replace this 1/4, one of the 1/4 by 1/3, then we have to decrease the value of 1/4. So there is only one option. Now if you picturize this, if you this understand, this is half. We have divided into 6 parts. So this is half and this is 1/3. This yellow part is 1/3. This is half. So what is remaining is only 1/6 is the only option. Right? So this explains why there is only one solution to the above problem. Right? If you want all three different, that there is only one solution, that is 1 upon 2 plus 1 upon 3 plus 1 upon 6 is equal to 1 whole. Now what if we look for 4 different fractional units that add up to 1? So can you find 4 different fractional units that add up to 1? It turns that this problem has 6 solutions. Can you find at least one of them? Can you find all of them? You can try using similar reasoning as in the cases of 2 and 3 which we used, or find your own way. There can be many ways you can reach to. So what we'll do, I'll explain you one or two and then I'll give you the remaining solutions. So if we start with this which we just understood, the 3 different fractional units which gives you 1. Right? Now here what we do, we try to replace this 3, we make it 4. How do we do it? Let us see. So now if we multiply this all by 2, all the denominators by 2. Okay. So what will happen? You are getting 1 upon 4 plus 1 upon 6 plus 1 upon 12. Right? Multiplying all the denominators by 2. Now when you solve this, it adds up to half. Right? It's add up to half. So now these are the 3 fractional units which add up to half. If we add half to this is half. If we add half to this, it becomes 1 full, because half plus half make whole. Right? So what is happening here? Half, and this 3 make half. So half plus half, that is 1 whole. So we have got 4 different fractional units to get 1 whole. This is one of the solution. Right? Now we'll try another with the same 3. 1 upon 2 plus 1 upon 3 plus 1 upon 6 is equal to 1. The 3 different units which we just used. Right? We solved it in the previous part. So we are using the same thing. Now what do we do here? We keep 1 upon 2 plus 1 upon 3 as it is, and we replace 1 upon 6 with 2 different fractional units which makes 1 upon 6. Now how can you find out that? By subtracting this from 1. Right? So what do we get? We get 1 upon 2 plus 1 upon 3, and we will get here as 1 upon 7 plus 1 upon 42. This will give you, this is replaced, 1 upon 6 is replaced by these 2. So we are getting 4 different fractional units to add up to 1. So basically either you will replace two of them to half, right? Two of them with 3 to make it half, or replace 1 upon 6 with 2 to make it 1/6. So you already have 2 and you find 2 other to make it 1/6 and you get the solution, right? So these are the 2 tricks. So we have already got 1, 2 solution. This is solution number 1. This is solution number 2. So I'll write the other 4. Just the third one, right? That is, we can take 1 upon 2 plus 1 upon 3, and this part is replaced by 1 upon 8 plus 1 upon 24. This will also give you 1 whole. Again, fourth one is 1 upon 2 plus 1 upon 3 plus 1 upon 9 plus 1 upon 18. This also gives you 1 whole, right? Then fifth solution is let me change the color so that it's easy for you, is 1 upon 2 plus 1 upon 4. Now 1 upon 4 is replaced by 1 upon 5 plus 1 upon 20. This gives you 1 whole. Right? In this case, what are we doing? We are replacing 1/4, half plus 1/4. What is remaining is 1/4. So we are replacing 1/4 with these 2 fractional units. The sixth answer is 1 upon 2 plus 1 upon 3. We keep the first 2 as it is, as in this case, and we replace 1 upon 6 by 1 upon 10 plus 1 upon 15. So 1 upon 10 plus 1 upon 15 will give you 1 upon 6. So it will naturally add up to 1, right? So these are the 6 solutions for 4 different fractional units to make it 1 whole. I have taught you 2 tricks, right? So either you replace 1/6 by 2 fractions or half by 2 fractions and get the answer. If you have some other tricks, you can share with me. Okay. So keep solving such puzzles. Enjoy doing maths. We have completed this chapter, fractions, and I'll start the new chapter, chapter number 6, which I have not yet made. I'll start that. So if you have not yet subscribed, kindly subscribe. Thank you.